Hello, everyone, and welcome. I'm excited that you could join us today for our launch of AWS IoT Core for LoRaWAN. My name is Michael McKenzie. I'm the GM for AWS IoT Connectivity and Control. And with me today is Priyanka Jindal, our Senior Product Manager. So just a few words about what we'll be covering today. I'll share a little bit about the background and motivation of why we chose LoRaWAN. I'll talk about our launch, and I'm going to share some of the use cases that we've gathered from our private beta program. Priyanka is then going to dive deeper into the product details and also discuss the great partner ecosystem that we're enabling for AWS IoT Core for LoRaWAN. So a little bit of background, I guess there's really no one-size-fits-all solution for IoT connectivity. There are a number of factors to consider, like distance and bandwidth, power consumption. So really, depending on your application, you need to pick the right tool. Wi-Fi, for example, is high bandwidth, short-range technology. This is great for things like smart home cameras, but the high power nature also means that they need to be plugged into the wall or recharged frequently. 5G and LTE offer great long range, but their high bandwidth also means that they use a lot of power and again need to be plugged in or recharged frequently. So this is a little bit inconvenient sometimes for wireless applications, and it relies on having a stable signal. Zigbee and Bluetooth are also nice options. They're lower bandwidth, but because they operate in the 2.4 gigahertz range, this range can be somewhat limited. And so this really brings us to these low power WAN technologies. Low power WAN or LPWAN is long range wide area network technology. And this is particularly useful when devices or sensors are located in remote areas, perhaps where cellular connectivity is spotty, or when you want to transmit a message data over long distances, or when you want to augment an existing sensor or control application with a wirelessly installed battery-powered stick-in-place sensor. LoRaWAN solutions provide a really great alternative in these cases. So in many cases, you need these sensors to last years on a single battery, and the low energy consumption of LoRaWAN is really ideal. It's also important to note, I think, that customers don't have to just pick one connectivity mode. Most customers who choose to deploy IoT in complex applications choose the right tool for the right job and may have a mix of different connectivity types throughout their architecture. And really, LoRaWAN has some excellent benefits. LoRaWAN can provide coverage over 1 to 3 miles in urban areas. So it's really ideal for applications like rideshare bicycle tracking or reading data from utility meters, or even used for predictive maintenance in industrial applications. In wide open areas, it even has a line of sight range of up to 10 miles. So this is a really great long range solution. It's also a great fit for indoor use cases like thermostats, door locks, even light bulbs, because it can penetrate between walls and floors of buildings or thick concrete structures, things like that. And I think the other thing is that the low data rates of LoRaWAN means that LoRaWAN sensors often have these huge battery lives, which is really advantageous, especially if these are put into difficult to reach situations or far distant situations. The other thing about LoRaWAN is that these sensors are really, really cost effective. And because there's little to no battery replacement, you save a lot of time on rolling trucks for maintenance and other things like that. And really, something else to really consider is that LoRaWAN, the specification is based on a security standard that only allows legitimate devices to be connected to the network. And it checks that the network traffic has not been altered and ensures that network traffic cannot be listened to or captured or replayed. So this is, it's built on a very secure standard, and this is, very important feature of LoRaWAN. I mentioned before that lots of companies use mixed connectivity for IoT solutions. And as an example, we're working with a company called Halter. Halter uses LoRaWAN to connect with actuators and sensors on dairy cattle in the field so that farmers can monitor the health and patterns of their cattle. But it's also really interesting. They use these collars on the cattle to actually be able to train the cattle and steer them on demand, so that we can get cattle, for example, to return to the barn when they're ready to be milked. Halter uses Wi-Fi in the barn for the high bandwidth operations, like updating the collars on the cattle. And it gives them a nice low-cost solution to use LoRaWAN out in the field compared to using something like a cellular device for the same application. We're also working with a global oil and gas company who's continuing their journey of digitizing their manufacturing operations in the field. This equipment is often located in remote areas, and they're constantly evaluating new ways of gathering data in order to optimize their maintenance schedules, things like that. Recently, this company decided to add temperature and vibration sensors to some of their equipment. And LoRaWAN really provided an excellent low-cost, wirelessly deployed solution for them to do that. Using these LoRaWAN sensors, they actually managed to replace a lot of ad hoc data checks and maintenance with predictive maintenance reports by automating the data collection and integrating that in with some machine learning algorithms. So a very, very clever system using these LoRaWAN sensors to augment their architecture. The new system provides operators better insight into their assets, helps them reduce unplanned downtimes, and of course does get them that magic bar of predictive maintenance. So a really interesting story there. Now, operating LoRaWAN does come with some challenges. Setting up LoRaWAN connectivity in a privately managed site requires users to operate their own LoRaWAN network server, or an LNS. And the LNS is used to manage the device connections to the cloud. So while data and devices can transmit over long distances, gateways are used to serve as a bridge and carry that data from those devices to the LNS, usually over Wi-Fi or Ethernet. And what we've heard from our customers is that setting this up can take days or sometimes even weeks, and involves hosting a LoRaWAN network server stack in their own cloud environment. And there's also a lot of additional overhead, operational burden, and maintenance associated with that infrastructure, and even just in providing technical assistance. And another, I guess, challenge that we've heard about is that, once they've set this up successfully in one location, it can actually still be really challenging to replicate the LNS solution to other sites or other geographies. And this wasted time really adds up quickly. This is time that you would lose for solving business problems, and is really undifferentiated work. So I'm very excited to announce today that we've launched AWS IoT Core for LoRaWAN. This is a fully managed capability to enable you to connect wireless devices that use LoRaWAN technology. You can set up a private LoRaWAN network by bringing your own devices and your own gateways and connecting them to AWS IoT with no LoRaWAN network setup required. No LoRaWAN network server setup required. This capability is generally available starting today, so we're really excited to announce it. What's great about this fully managed LNS is that we've eliminated the undifferentiated work that I mentioned earlier, and that operational burden required to set up and manage the LNS and the associated infrastructure. We've also provided built-in integration with other AWS services like Dynamo, S3, through the IoT Core rules engine. We can also connect to analytics, machine learning, and really you can take advantage of that full AWS application ecosystem now by connecting your LoRaWAN devices. We've also made it easy for you to onboard your devices and gateways with support for the LoRaWAN standard, an open source gateway software, and a gateway qualification program. Priyanka is going to discuss this in more detail later in the presentation, but our ecosystem is a really big strength of this launch. And maybe best of all, you really only pay for what you use. We've provided consumption-based pricing that we believe will save our customers a lot of money compared to DIY or third-party service options. So through our beta program, we've been working with a company called ComplianceMate. And ComplianceMate provides food safety systems for quick-serve restaurants like Chick-fil-A, Shake Shack, and Five Guys. They enable quick-serve restaurants to maintain compliance to food safety regulation and perishables. And ComplianceMate is using AWS IoT Core for LoRaWAN to connect temperature sensors in restaurant refrigeration and freezer units. These LoRaWAN device signals can penetrate the thick walls of these refrigeration units, and they can last for years without battery replacement thanks to their low power consumption, which overall reduces their operating costs. The combination of the wirelessly connected temperature sensors and real-time access to the temperature data means that ComplianceMate's customers can quickly identify operational problems and prevent food safety mishaps before they occur. So I really want to thank them for being a part of our beta program and learning with us, but a really interesting use case for using LoRaWAN sensors. We've also been working with a company in the smart connected buildings area called Quext in the multifamily dwelling space. And the solution that Quext provides allows property managers to provide safer buildings and lower utility costs for their owners. Quext uses AWS IoT Core for LoRaWAN to provide connectivity for wireless connected home devices across the entire property without the need to manage their own custom LNS backend solution. And one of these devices is a connected smart home thermostat. This not only allows them to manage the energy efficiency of the building better, it allows them to use the thermostat as a connected home gateway for other LoRaWAN-enabled devices. So a really cool application. As an example, they connect to the LoRaWAN-enabled smart door locks, which allows property managers to remotely rekey units after a tenant vacates a property, but also increases the building security and efficiency. And AWS IoT Core for LoRaWAN allows them to replicate this solution really quickly across multiple properties. So another really great example there from one of our customers in the beta program. And again, I want to thank them for being part of our beta program. We certainly appreciate learning together. So I'll pass over to Priyanka now to talk a little bit more about the product details.
Thank you, Mike. Hello, everyone. Super excited to be here today to tell you a bit more about AWS IoT Core for LoRaWAN. AWS IoT Core for LoRaWAN offers you 5 integrated features. First of all, connectivity for your LoRaWAN devices, so that you can connect hundreds, thousands, or even millions of LoRaWAN devices with zero LoRaWAN network server setup required. To set up a private network, you also need to connect LoRaWAN gateways. AWS IoT Core for LoRaWAN provides gateway management service so that you can connect your gateways securely to AWS IoT Core and manage them remotely at scale. Third, integration with AWS IoT Rules Engine. It provides a built-in integration to automatically route messages from connected LoRaWAN devices to AWS IoT Rules Engine so that you can accelerate your IoT application development. Fourth, it provides visible device and gateway health so that you know what's going on with your connected devices and gateways and have the ability to troubleshoot issues. And lastly, AWS IoT Core for LoRaWAN qualified hardware program so that you can source pre-tested gateways and developer kits from our manufacturing partners to get started easily. Now let's look into each of these features a little bit deeper. AWS IoT Core for LoRaWAN provides a fully managed network server in the cloud, along with LoRaWAN device provisioning and gateway management service. So you can just bring your own devices and gateways and then connect them with AWS IoT Core for LoRaWAN using our console experience in a few simple steps. Let's dive into the gateway provisioning and management features. In LoRaWAN networking, gateway is the physical layer interface for the LoRaWAN network server. And LoRaWAN gateways run a software called Packet Forwarder. As the name suggests, its responsible or its primary function is to forward messages from your devices to the network server in the cloud. For AWS IoT Core for LoRaWAN, we decided to support LoRa Basic Station, which is an open source implementation of the LoRaWAN packet forwarder. We supported Basic Station for a few different reasons. First and foremost, its security and gateway management features, and then secondly, its adoption in the market. For security, the gateways can obtain a server trust, client certificate, and private key from AWS IoT Core. And then a TLS mutual authentication is established before the messages are exchanged. For remote management, Basic Station supports a protocol called CUPS, Configuration and Update Server Protocol. AWS IoT Core for LoRaWAN provides you a managed CUPS server for configuring both your AWS IoT endpoint on your gateway and for distributing firmware updates during the gateway management lifecycle. And lastly, and very importantly, Basic Station is being adopted by leading gateway manufacturers. The source code is distributed and maintained by Semtech, the company behind LoRa technology. So all of these things made us confident that with Basic Station, our customers will find it easy to secure the right hardware without the need to develop or test custom gateway software. Now let's look at how the device connectivity features work. AWS IoT Core for LoRaWAN supports LoRaWAN specifications 1.0.2, 1.0.3, and 1.1, so that you can purchase any compliant LoRaWAN device, sensor, or actuator and be sure that it will connect with AWS IoT Core for LoRaWAN for a plug-and-play experience with no embedded software development required. LoRaWAN supports two ways of provisioning a device and three different classes. These classes support different power and latency requirements to support a wide range of application needs. Customers can also register, so AWS IoT Core for LoRaWAN supports both ways of provisioning a device and all three classes. Customers can also register LoRaWAN device profile to define supported data rates, configure channels, and other settings, which will be used when LNS communicates back to the device. For data protection and security, AWS IoT Core for LoRaWAN ensures that device traffic coming through the gateways belong to the same AWS account, and the device traffic will be discarded if the devices in gateways do not belong to the same account. All the data sent to AWS IoT is sent over a TLS connection, established by the gateway in this case. So it is secure by default in transit. And for AWS IoT Core for LoRaWAN, we use AWS managed keys to encrypt the data at rest. When bringing the power of cloud connectivity to your devices, the primary goal of our customers is to be able to reason on top of that data collected from your devices. And it's of course desirable to do so without having to manage any infrastructure or without having to use different cloud platforms for your connectivity and application needs. AWS IoT Core for LoRaWAN integration with AWS IoT Rules Engine solves for this problem. When you register a device with AWS IoT Core for LoRaWAN, you will also specify a rule name that would process the messages coming from the devices in real time. Rules Engine transforms the messages based on the expressions that you define, and then routes them to AWS services of your choice for analytics, database, storage, and so on. For example, a routine reading from a temperature or a vibration sensor could be tracked in a DynamoDB table. Or if an abnormal reading is detected, you could set up your application to trigger a notification using Amazon's simple notification service. One thing to note is that payloads sent by LoRaWAN devices are encoded. And this is due to the need to optimize the bandwidth used by devices. So as you set up your rules in AWS IoT Rules Engine, you can include a decoder step that invokes an AWS Lambda function and then route the decoded messages to downstream AWS services. So this diagram brings the whole picture together. You can see the uplink data flow from the devices to the application, which is being routed through AWS IoT Rules Engine. and then the downlink flow from the application back to the devices. When your application sends messages to devices, AWS IoT Core for LoRaWAN selects the optimal gateway to send those messages to your target devices. As we ran our private beta program, we learned from our customers the need to have visibility into the device and gateway status so that they can know what's happening with the devices, when the devices are active, when they are transmitting data as expected, versus where there are issues which require troubleshooting. To help engineers gain visibility into the fleet status, AWS IoT Core for LoRaWAN enables customers to query the status of devices and gateways on the console and as well as through APIs. For each device message, you can query the transmission data. For example, the device frequency and data rate, the gateway that received the data, and also the quality at which the gateway received the data. For example, its signal to noise ratio. Lastly, we also have logging capabilities provided through Amazon CloudWatch so that you can visualize event logs in real time and have a visibility into what's going on with the gateways and devices that are registered in your AWS account. We wanted to make it really simple for you to get started with the service by simplifying your hardware discovery process. So we are very excited to launch AWS IoT Core for LoRaWAN Qualified Hardware Program. Starting today, we have 12 gateways and 4 developer kits available from our manufacturing partners, ready for purchase at AWS Partner Device catalog. AWS qualified gateways and starter kits are pre-tested to make sure they meet the basic station software requirements and desired configuration, and they include a step-by-step guide by the manufacturer on how to connect this hardware with AWS IoT Core for LoRaWAN. Next, I wanted to put a spotlight on the work we have been doing with AWS partners, since they are incredibly important to the success of our customers. As part of our AWS IoT Core for LoRaWAN efforts, we partnered with 3 leading system integrators, Clickatek, Leverage, and Tensor IoT, all of whom offer design and integration services to help our customers quickly build applications and develop proof of concepts. For example, Clickatek provided the smart building solution used by Quext, the customer whom Mike discussed earlier in the presentation. Leverage also provides an asset tracking solution built on top of AWS IoT Core. And in a joint partnership with Tensor IoT and Semtech, we're also excited to bring 2 LoRaWAN solution starter kits for smart building and asset tracking. Using these kits, customers can easily build a proof of concept with access to a cloud-hosted dashboard provided by Tensor IoT. For example, using their industrial kit, you can connect sensors and then track the assets and visualize them easily on a map in the dashboard. These kits are also immediately available for purchase at Amazon.com and other websites. So if you're excited to try out AWS IoT Core for LoRaWAN, you can purchase the AWS qualified hardware, the gateways, or the developer kits at AWS Partner Device catalog and then log into AWS Management Console to get started. You can also find sample LoRaWAN solutions from our partners and solution architects at AWS GitHub repository. With that, I'll hand it over back to Mike to talk about our partnership with Semtech.
So thanks, Priyanka. I wanted to give a special mention to Semtech, who have contributed to the AWS IoT Core for LoRaWAN journey and all of our related activities. For those of you who are unfamiliar with Semtech, they are the company behind the LoRaWAN technology and all the LoRaWAN technologies. Mohan from Semtech shared with us that this is not just about offering our customers a single pane of glass for their IoT connectivity and application development, but it's really about empowering AWS customers to take advantage of the long-range, low-power data communication that is revolutionizing IoT across a ton of different use cases, a ton of different applications, from smart home to industrial to urban and indoor and outdoor. So we really appreciated Semtech's involvement, and again, I just wanted to thank them a lot for their involvement throughout our process. Thank you for joining our session. With that, thank you very much, and please fill out your session surveys. Thanks very much.